Hello, my name is Daniel Valcour, otherwise known as Journeyman, and in this video I will be creating a C++ application from scratch using CMake as well as Visual Studio Code, and I'll be integrating CMake into Visual Studio Code using the CMake tools extension, and also I will link with my application the SDL2 library. So I'll just show you, this is just a basic demo of how to get all this stuff working. And of course I'm using Fedora Linux. This will work on pretty much any platform. So you need to make sure you have CMake installed. You need to have Visual Studio Code installed. You need to have a compiler installed on your computer. And all this should work just fine. So I'm just going to go in here and I'm going to make a new folder and I can call it my project. So SDL2 project. That's what I call it. Okay. That seems a good enough name as any. And right click and open with Visual Studio Code. Okay, so when you're working with CMake in Visual Studio Code, the best thing you can do is get the CMake tools extension. Go in here, and then you go C++ extension pack install for Microsoft, the one from Microsoft, and include CMake tools extension, and that's all you need. Okay, so now we're going to make a file here called CMake list.txt, and this is where we're going to write our CMake script. So CMake is a scripting language. I can use it to define how you want to build your C++ projects. It's kind of interesting scripting language. It's not actually very simple. Yeah, so whenever you make a CMake list file, for a top level one for your project, you have to always call this function first. CMake minimum required. It's a CMake function. It's a version, and what version of CMake do I want to use? This is basically CMake, multiple versions of the tool for CMake comes out, and features might be depreciated in later versions, or maybe you want to use advanced features that are going to come out in later versions of CMake. You can specify right here the version that you require people to have at the very minimum to be able to use your script. So I'm going to use the version that I have installed on my computer, which you can do by opening a terminal like I just did. You go terminal, new terminal, and you go CMake -s version. So the version I have installed on my computer is 3.28.3. So that's all you do, 3.28.3. There we go. That's good. Okay, now I'm going to define my CMake project. So you go with the project function, and then you just define the name of the project, SDL2 project. This is not the name of an executable or anything I'm building. This is just the name of the entire project. Of course, I want to make an executable now. And let's just make a really simple one just to show how the basics work. And I can call this my app. And I can have one file main.cdb. Okay, so this is a very basic CMake script to build a simple executable with no library linkages or anything. It's very simple. It really is pretty simple, actually. A lot of people get really confused with it. They think it's scary, but it's actually not that hard. Sometimes, when you're looking at CMake code made by people, they might be using older versions of CMake. They might be using some really nasty looking code, confusing code. But if you're using like the modernmost stuff of CMake, you can really write stuff really concisely. And that's kind of what I'm showing you how to do in this video, so pay attention. Alright, so now we're going to make this file main.cdb, and we're just going to do it right here. And we're just going to do a basic hello world application. So just to get things started. And I'm going to use SCC out because I'm not interested in using really modern C++ stuff. I'm going to use like whatever version of C++, probably 17 is what it's going to turn out to be. Okay, so there we go. So this script will then take the main file and make an application called my app, right? So you have to use the CMake extension. Now I might get confused. You might go over here and click this little debug icon and be like, let's run a debug, but no, that's not going to work. This is something entirely different. This is not CMake. This is not CMake tools extension. This is something else built into Visual Studio Code. And you don't want to use this. It's very annoying, might be confusing, but just don't use that. So we need to use the CMake tools extension. So there should be an icon here you click on, and it's not here. So if this happens to you, what you do is you close out, and then you just like, I ignored that. Then you open up this, and open with, and then Visual Studio Code, and then okay. And then was this? Oh yeah, just ignore this. Sorry, that was a trial run for this video. Just ignore that. Okay, so CMake, and then all you have to do, see this new icon appears here now. This is CMake tool extension. This is all the options and stuff in it. If you want to build or configure your projects, everything you need to do is right here. I mean, sometimes you might want to give your settings or whatever, but yeah. So this is really everything you need to do to get it up and running. And you click this button right here, configure all projects, and there we go. See, it ran CMake and it configured my project. So build files have been written to this folder, SDL2 project/build. So if I go into this folder and look, so here's the main I made, here's the CMake list file I made, and here's the build folder. This is new. This was just created by CMake for me, and it has all this stuff in it. CMake needs to build the project, and yeah, it's a little weird, but you don't need to worry about it. It's going to do everything for you. So if you look at this SDL2 project, this is the project. My app is the executable. If I had more executables or libraries in this project, they would all be listed here. And when we add SDL2, it will be listed in this list, and so you'll see that. But for now, we just have my app and we're going to build it. Just right click and I click build, and we just built the application. So if we go back in the folder, if we go back into the folder, and there it is, my app. So I'm using Linux, so it doesn't have a .exe, it's just like written like that because that's how Linux applications are written. No file extension, but yeah, it's right there. So if you want to run it though, we don't have to, we can double click it and run it right here, but I'm going to do it from in here, right click, and then run in terminal. And there we go, it ran it, and you can see the terminal output, hello world. So it worked. Ignore all this junk around it, it's just kind of weird stuff, I don't know. Right click and go debug, and then it'll build it again, but in debug configuration. So here's the debugging console, which I can add breakpoints. I can like add, well, this is a CMake file. I add like breakpoints, and it will debug break while I'm running in debug configuration. See, it stopped, and I can step and whatever. See, it printed hello world, and then it's done. Pretty cool stuff. All that stuff is you're ready to do debugging and everything you need to do to work on your code. So that's pretty cool. See, you printed the output hello world. Really awesome stuff. Now we're going to add SDL2 as a dependency, and that's the final bit of this video. So there are many ways to add dependencies using CMake, and for this video we're going to use something called fetch content, which is a kind of a modern way of doing it, which is really awesome. It will basically download SDL2 source code from online, it will compile it, and then it will link it with your project, and it will work. It's great. So I'll show you how to do that. First, you have to include something. You include fetch content. Okay, fetch content. So fetch content is a CMake include. So it's kind of like include outstream is C++ include. It's the same sort of idea. It's just gonna copy a bunch of text from this include file and paste it in here. It's like it's somewhere in the CMake build system. I don't know where, but whatever. So fetch content is what you gotta call. It's a function that I just got from this include. Fetch content declare. We'll include SDL. Let's just call it SDL2. The name you define here does not matter. We can call it SDL2, and then we can define our options. And so in this function, you say like the option name and then the value, the option name, the value, in that way. So we're going to say the first option, get repository. It's basically going to tell CMake we want to download SDL from this repository right here. Whoops. On GitHub, yes, it's SDL2 official, GitHub, whatever. So copy the link and just paste it right there. There we go. And then we say get tag. Get tag. And then if you go here and then you click tags, these are all the versions of SDL that are on this GitHub repository. You can select the version you want to use. So I'm going to use release 2.3.30.0. You can also go to commits and pick an individual commit, and then just like a little number right here. You can use that number, and it should be able to find it. Just that should be enough. Just that little number right there. You can just paste that in here. But we want to use a official release, so we can go to tags, and we're going to give release 2.30.1. So that's the version of SDL we're going to use. And I say spelling error content. There we go. And then we go fetch content. Okay, now auto completion messed me up there and included it. That's not what I want to do. Fetch content. I'm just going to make available, and then you just say the name of the target you want to make available. So when you do this, this is when it's going to go in the line and download the SDL2. And there's a whole bunch of other things you can do. You can like configure options for SDL2. You can also use something called find package. You can use it instead of fetch content. You can like find a package from a package manager on your computer. Now, if you're using Windows, there is no package manager on Windows, but you can use something like VC package, which is a package manager you can kind of embed in your project. But we're not doing that. We're just going to do fetch content. This will work on pretty much every operating system. It will download the source code and compile it, and it works. So the downside is it has to download the code every time, download a source code from online, but it's not that big of a deal. So, and then the command make available. Did I really spell that wrong? Okay, come on. Make available. Make avail. I'm very tired right now. No, it's working. I spelled it wrong first time, but now I spelled it right. Okay. See, English, yeah, okay. So now it's configuring, and you can see it's this is actually SEL stuff right here. See, so CMake, I just did a configure. So if you edit the CMake file and you save the file, it will reconfigure automatically. Basically like pushing that button, it will do it for you automatically. You can see it actually it's SEL stuff here. So it actually did. It downloaded it, and it's the CMake configuration for SEL. Because SEL actually has its own, has its own CMake list file, and see, it has its own script, and yeah, so it's running all that stuff. You don't have to worry about it, really, but yeah, that's what it does. So then we can go here and we can go, we have SDL, but now we want to link it with our application. So we go target, link, libraries, right? And then we go name of our app, which is my app. And then we have to say an accessibility modifier. So we're just going to say private. It doesn't matter because it's executable. For now, we're going to say private, and then we just say SDL2. Now, if this was a library target, like I could go add library, mylib. This is just for example purposes right now. Let's make it be a static library. No, mylib. That's this is source file. Okay, let's say I had a library like this, and then I wanted to link SDL to this library, and then I wanted to go target link libraries. My app, and I want to link my app to my lib, right? This is where this public-private stuff actually matters, this type of situation. So if this, see, my lib links to SEL, and then my app links to my lib. So if this is private, that means that my app does not have access to SEL because see, it's private. But if I make this public, then my app would actually gain all the links to my lib that were public. So it would also gain SEL directly, right? So that's the point of that. But yeah, we're not doing that right now. I just want to explain what that means. So yeah, we're going to make this be my app. Okay, and just to prove that's working, I'm going to include SEL. See, it's actually finding the includes because it's linked correctly. SDL2H or something like that. Oh, come on, what is it? Let's include file again. SDL. That's not right. Okay. SDL. Okay, if it's doing some weird thing where I can't find the file in code completion, then you might need to just like reconfigure the project. So I'm going to delete the build folder. But yeah, if you have any weird issues, like, and also if you want to add new source files to here, like I might want to add a new source file, like my older file SVP, you know, then you might want to just do, this is a little trick you can do, delete the build folder and then reconfigure it and it will fix things. That might fix this error right here where I can't find the include IntelliSense. Because I'm trying to include SDL2 and it's not working. Okay, give it a second. Let's see if I finish. Okay, so it's doing a lot of stuff. SDL2 that has a lot of features in it, so it's going to take a little bit of time for CMake to finish. Yeah, give it a second. And a second out. There we go. So I'm going to include SDL2 slash. Okay, what am I not seeing? The right include file. Go here and build. So I'm building the SDL2 library right now. See, because this is my CMake project, I can right click and build it. So this is my project, my app, and this is the SDL2 stuff that it added when I did that stuff right there. So why is this not working? Include SDL2. I try to make a video. There we go. SDL2 SDL.h. Okay, so that's what I had to do to get it to actually work. That's right. It was called SDL.h. I couldn't remember what the file was named, so I needed IntelliSense, and I had to build the project before it actually like kicked in. But there we go. So now if I build my app, so I'm going to delete the build folder actually. Do everything from scratch just to show you something. So configure CMake, and then if I build my app, well actually it's still configure CMake, so I have to wait for it to finish. So if you try doing too many things over too quick, it's going to like spit at you like this. Just wait until it's this little spinny thing's done. Yeah, you click on it, you can see the output for that action. I'm going to wait for that to finish again. Alrighty, come on. So I can right click here, I can go build my app, and you can see it's first going to build SDL because SDL is linked to my app, so it needs to have SDL for the app to build. So CMake can do all that for you. That's pretty cool, right? And I can go build and I can run it. And when you do debug, it's going to build it in a different configuration, so it's going to rebuild everything again. Whoops. So there we go. Hello world. But I included SDL, so it actually found the header file. I didn't have a compiler error, which is pretty cool. And I can also, just for the sake of, showing something in SDL, I'm not going to make a window or anything. I'm just going to do something basic here. I'm going to go A scan code. I'm going to go SDL K A. So this is the scan code for the letter A. SDL K. Why do you say the letter A? Oh man, come on. SDL K, keypad, come on. Oh, it's just lowercase a like that. Okay, that's cool. So there's the SDL A key. So scan code, and it'll print it out to the console. So that's the scan code for the letter A on an US keyboard. Okay, pretty cool. Of course, I could do anything. SDL will work just fine now. And linked it. And if you want to change your compiler you're using or whatever, you can have to Visual Studio Code. You can hold down Shift and Control and then press P, and then this thing called the palette comes up. So it's Shift, Control, and then P. And so you can actually do all this stuff over here and here too. It's like Option CMake configure. That's the same as clicking that button right there. And there's a whole bunch of other stuff for different things in Visual Studio Code other than CMake tools. But let's say you want to change the compiler we're using, you can do select a kit. And now I can select, I want to use Clang, I want to use GCC, I'm going to use Clang for Windows. This is because I have Wine installed on my Linux computer. And if you're using Wine compiler, and you're trying to build for Wine with CMake tools, it won't work, so don't do that. But I can use, I'm using Clang right now, let's change it to GCC. So now I'm going to use GCC compiler and build and run an application. So yeah, this is, and after that point I'm going to end this video. Let's see. It has to reconfigure everything once you get a new compiler. and then I can go debug and I have to rebuild everything. This is the joy of C++, is that it takes a long time to build stuff. And this is only a very small application. Imagine like a game engine like Unreal Engine probably takes like 30 minutes to build the whole thing. It's pretty crazy. But here we go. This is it ran, printed scan code, but I used GCC compiler this time. Alright, so that's the end of this video. I hope you have a wonderful day. If you have any questions, you can find me on the Better C++ Discord. The link will be in the description of this video. Thank you and have a great day.